Today we are going to continue looking at factoring trinomials. And when we're factoring a trinomial such as a x squared plus bx plus c, we know that we want to factor it into two binomials. And it depends on if a is 1 or not 1, which method we take. So the difference here now is that instead of just putting an x squared and an x there, or an x to the fourth and an x squared there, etc., we are now putting a binomial in place of our x. So what we're going to do here is we're going to just use the same thing we did with our difference of squares. We're going to use our ability to substitute. So we're going to let w, or whatever variable you want, be x minus 5. And we're going to replace x minus 5 with w. And then we're going to factor this. Since it's a 1w squared, I'm going to find two numbers that multiply to give 12 and add to give 8. And now that I have factored it, I now can replace x minus 5 for w back in here. Okay, so w is going to become x minus 5, and then you have minus 6. And then w is going to become x minus 5 and minus 2. All right, since after this substitution is happening before the subtraction sign, it is not a big deal in terms of the brackets, but I put it there because it's always handy, because if we had a binomial after the subtraction, we'd have to be careful that that subtraction goes to both. But at this point, all we're doing is collecting like terms. And we collect like terms, right? And now I look to see if I can simplify each factor. I can't, so now I have completely factored this with the use of substitution. So let's try this one. Again, I can see I have a binomial that exactly matches that binomial, so I can use my substitution, and I can let w be 2x minus 3, and I have w squared minus 5w minus 14. Going ahead and factoring it, I get w minus 7 and w plus 2, replacing the 2x minus 3 for w, and again, w is just at the front with no multiplication, so I'm not going to worry about the brackets right now. And so I get 2x minus 3 in place of the w, and then I have plus 2 after, right? So it's the 2x minus 3 that's replacing the w in each of those binomials. Now I can collect like terms, and I get 2x minus 10 and 2x minus 1. And again, at this point, we look to see if a binomial has a GCF or is a difference of squares, right? They're no longer trinomials, so I'm not looking for that method. I can see a GCF of 2, so I write my 2 out front. Okay? Even if the GCF was here, I write my 2 way out front. And I divide it out. This is prime, can't be factored, so now I write it like that, and that is completely factored. Again, order doesn't matter. If the x minus 5 came second and the 2x minus 1 came first in those two binomials, it doesn't matter. But I would always put the monomial way out front in the beginning. Okay. All right, so here again, I have my two binomials that are identical, so I'm going to use my substitution. This time, though, I get 3w squared plus 7w minus 6. And now I have to use one of my methods for when a is not 1 and there's not a GCF. So I need to either use my guess and check, my AC method, or my decomposition. It's your choice. Whatever choice you like, you choose that method. I'm going to use a guess and check, so I'm going to split my 3w squared into 3w and w. I'm going to find numbers that multiply to give 6, and I'm going to guess and check such that the outer and the inner product gives me my 7. So I would not put the 3 here or the 6 here because that would give me a GCF, so I'm not going to do that. But let's say maybe I want to put the 1 here and the 6 here. That gives me 18 and 1. That's not going to work. So let's try the 2 and the 3. Let's put the 2 here and the 3 here. I'm going to get 9 and 2. 9 minus 2 is 7. So that works. Since there's more 7s, I'm going to put the greater product to be positive and the smaller product to be negative. There we go. We've completely factored. Now I'm going to substitute the x minus 4 back in place of w. But this time the brackets are super important because w is being multiplied by 3. Here, the brackets are not super important, but I'll put them in just to show you that it's the substitution. So now I'm going to use my distributive law, and I'm going to get 3x minus 12 minus 2. And over here, I just have my x minus 4 plus 3. Collecting like terms, I get 3x minus 14. And over here, I get x minus 1. Okay, so this is not factorable, this is not factorable. So I've completely factored using substitution. All right, let's try one more. Here, I'm going to let w be my 2x minus 3 again. I'm going to get 2w squared plus, there's no number there, so it's a 1w, right? Or you just write w minus 15. I'm going to factor this into 2w and w. I'm going to try 3 and 5. That gives me 6 and 5. That works out. And I need more positives. So I'm going to make the 6 a positive and the 5 a negative. Let's double check. That's positive 6w minus 5w. That gives me 1w. Good. Right? The signs had to be different because my product was negative. Now I'm going to substitute my 2x minus 3 back in place of w. And then I'm going to collect like terms and use my distributive law. So I'm going to get 4x minus 6 minus 5. And over here, I'm going to get 2x minus 3 plus 3. So that just becomes 2x. So now that that's a monomial and not a binomial, whenever it's a monomial, I would always write that out front. So I am going to switch the order just because that's what we're used to seeing. And then because it's not being added or subtracted, like it's not 2 plus x or 2 minus x, I no longer need brackets around it. It's just 2 times x times this factor. So I'm going to write 4x minus 11 as I collect like terms. So if it's ever monomial, I would then put it out front. All right, last one. Again, sometimes we say, well, they look alike, but they're not quite the same. If it was addition, they'd be completely the same because order doesn't matter. But with subtraction, I would factor out a negative 1 out of here, and then I could write that as x minus 1. By factoring out a negative 1, since there's already a number, I'd multiply them. 21 times negative 1 is negative 21. So now I have these both being x minus 1, so I'm going to let w be x minus 1. And I'm going to get 4w squared minus 21w plus 5. And we're going to factor this. Maybe let's try our AC method just in case some of you like that method. I'll do that method here. So I'm going to get w squared minus 21w plus 20, which becomes w minus 20, w minus 1. Right? Multiply to give that. Divide both of those by 4. That reduces down to 5. And that becomes 4w minus 1. Okay, so if that's the method you like, you could always do it that way. Now I know w is x minus 1, so I'm going to substitute x minus 1 in place of w. So I have w minus 5, and then I have 4 times w, using brackets when it's multiplication. And now I need to collect like terms distributive law. This is going to give me x minus 6. This is going to give me 4x minus 4 minus 1, and so I'm going to get x minus 6 and 4x minus 5. Right? I can't factor, I can't factor. So when you're doing your homework, little things that you need to do, practice that substitution, etc., little tips and hints. For example, if I looked back up here, if I gave you this question in your homework and it was 3x minus 4 squared, but instead of it looking like that, I could have it looking like this, 7x minus 28 minus 6 or something like that. You would be able to recognize that you can factor a 7 out of those two and get to this step here, right? So it's a little more complicated than in the homework, but you can, those are little tips for the harder questions, right? But as long as you got the idea of the substitution, then you're good to go.